This problem is asking us to find all of the roots of x cubed plus 5x squared minus 4x minus 2 equals 0. So the first thing that we can do is use the remainder theorem to determine all possible roots. That is going to be a ratio of our factors of our constant, negative 2, over all of the factors of our leading coefficient, 1. So factors of 2 are 1, negative 1, 2, and negative 2. And we can put that over 1. We can put them all over negative 1 as well, but that's just going to give us duplicates. So we have 4 possible roots. If we plug these back in using the factor theorem, we can determine if any of these are possible roots. So let's start with plugging in 1. 1 cubed plus 5 times 1 squared minus 4 times 1 minus 2 equals 0. 1 plus 5 minus 4 minus 2, 6 minus 4 minus 2, 0 equals 0. So we know that yes, 1 is a root. It's one of them. So the next thing that we can do is we can factor out 1 using synthetic division and see what our result is. So our coefficients we would use are 1, 5, negative 4, and negative 2. Bring down the 1. 1 times 1 is 1. 6. 1 times 6 is 6. 2, 2, 0. So what that tells us is now we have x minus 1, because the 0 for x minus 1 is 1, that's where the 1 comes from, times x squared plus 6x plus 2. Looking at x squared plus 6x plus 2, I don't think that I can factor that very well, so I could try to complete the square instead. So if I have x squared plus 6x equals negative 2, I need to do b over 2a. So b is 6 over 2, b over 2 squared. Getting that confused with my vertex. And that's 9. So to complete this square, I'm going to add 9 to each side. 9 plus negative 2 is 7, so I can just combine those like terms. Now I can factor the trinomial, find the square root of each side, and solve for x. And I know that 3 minus the square root of 7 is also a root using the irrational root theorem. So now I know what all 3 of my roots are. X minus 1, x minus 3 plus the square root of 7, x minus 3 minus the square root of 7. Using the fundamental theorem of algebra, my original problem was x to the third, a third degree polynomial, which meant I should have 3 roots. So the fundamental theorem of algebra says I have found all of the roots, so we're done.